Dear students, detailed civil engineering courses like Manual Building Design, Stat Pro, ETABS, SAP, Revit, AutoCAD, Primavera, P6 are available at Civil Engineering Shravan online application app. So download the application from the Google Play Store now. Each course contains 50 plus high quality video contents and free PDFs and exercises, and online certification will be provided after completing the course. Course will be available at 67 to 70% discount now and valid up to 6 months. Download civil engineering application now from Google Play Store, or direct link is available at the description of this video. Try to utilize this offer. Please click on subscribe button and click on bell icon for more interesting updates on civil engineering concepts. In this video, I will explain you complete details about the primary school design by using ETABS software. So for that reason only, just I am considering the primary school building architectural plan here like this, which is consisting of four classrooms. So this is the first floor for the primary school. In the ground floor, it is consisting of the same amount of the layout for the particular structure, but it is having some modification in the architectural plan. So this is the first column, this is the second column. In the same process, this is the third column, this is the fourth column, this is the fifth column. Again in the same process, it is consisting of the columns here 1, 2, 3, 4, 5. Again in the same process, I am considering these columns. So for this plan, it is consisting of approximately 5 multiplied by 4, which is a 20 number of the columns here for this structural plan. So again, it is consisting of same amount of the column layout, beam layout for the particular structure. Now we will assume the center to center distance between the column for this particular plan. So here I am selecting this horizontal distance is 5 meter for each and every floor. Just I am considering here 5 meter, 5 meter. So again in the same process, vertical direction, just I am assuming this is 6 meter, this is 6 meter. Again this corridor, it will be consisting of, just I am considering 3 meter here. So the number of lines in horizontal direction consisting of 1, 2, 3, 4, 5 numbers here, and vertical direction it is consisting of 1, 2, 3, 4 here. The length of the building is approximately 20 meter and width of the building is approximately 15 meter. I am assuming for G+2 building structural model. So for that, initially we will select the ETABS software here. Since I am considering G+2 building structural model, which is consisting of the plinth level, ground story level, first story, second story, total 4 stories for this building model. Go to click on the file option here, click on new project option. Firstly, we will select the units and code books according to our consideration. So here I am selecting user built-in settings option and select the length units will be in metric SI and steel section will be Indian code, and according to IS 800, concrete is IS 456. Click on OK. Now we have to enter the number of the lines in horizontal direction as 5. Y direction will be consisting of 4. Each will be consisting of 5 meter in horizontal direction, and Y direction just I am assuming here as 6 numbers here. So just I am taking 6 here. Click on custom grid spacing option. Click on edit grid data. Select display as spacing option here. So it will be consisting of the distance is 5 meter. Again it will be consisting of the Y spacing as 6, 3, 6 here. Click on OK option. Now we will enter the number of the stories. Just I am entering the number of the stories will be consisting of 4 numbers. Each will be consisting of 3 meter, 3 meter I am assuming here. Click on grid only option. Click on OK option. Now you can see here, this is the plan model and this is the 3D model for the building. Go to select your defining the material properties like M25 grade concrete I am assuming and Fe 500 grade steel. Click on material properties for that. Click on add new material. Just I am selecting Indian code concrete which is related to M25 grade concrete provision. Click on add option. OK. Again in the same process I am adding the rebar which is related to the HYSD bar of 500 grade. Click on OK. After this we will define the cross section for the columns and beams. Go to define option, section properties, select frame section. So delete multiple properties. Just I am selecting here. Click on delete option. Again we will select this. Click on OK. Now we will add the column section initially. Just I am selecting the column which is consisting of approximately dimensions of 0.3 cross 0.3. Just I am taking here. Again it is consisting of material is M25 grade concrete provision with depth as 300, and width is also 300 here. And click on the reinforcement option. So here we have to select the column which is of HYSD of 500. Just I am selecting 3 by 3 bars, otherwise 4 by 4 bars which is exist for this particular column section with 16 mm diameter bar and 16 mm for the both bars. Again in the same process I am selecting confinement bars of 8 mm diameter. Click on OK. So now we have to select the cover for this particular project which is consisting of 10% of the higher dimensions. Click on OK. Now we will click on OK option. After this select ISLB, delete property option. Now we will define the beam section property. Just I am selecting the beam which is consisting of the dimensions is approximately 0.3 cross 0.23. I am assuming for this model with M25 grade concrete. Depth as 300 here and width as 230 approximately. Click on reinforcement option. Select beam only. So select HYSD bar of 500. Just I am taking 30 at the top reinforcement section and 30 at the bottom reinforcement section. Click on OK. Click on OK option. Again we will click on OK option. Now we will define the slab section. Go to define option. Select section properties which is related to slab section. Click on delete option. Click on OK. Now I am defining the slab which is consisting of approximately 125 mm with the material as M25 grade concrete with 125 mm. Click on OK option. Again we will click on OK option. Now I am selecting one story option to all story option in order to assign the properties. Just I am selecting this beam assignment property. We will check that whether it is comes under the beam or not. So it is column here, but we will change that to beam section. Just I am assigning here like this. Again in the same process we will assign for the column. So select I section. Just we will select as column. Just I am dragging here like this. Again in the same process I am selecting the slab sections here. So which is related to slab 125. Just I am drawing here like this. So now we can say this is the drawing which is of plan model and this is a 3D model. Now initially we will delete the slabs at the ground story level. Go to select option for that. Stories. Select the base initially. Click on delete option so that it will delete the property at the base level. Again in the same process we will come to the top story for this building model. Now I will come to the top story. So here I am coming to the next story which is related to the plinth level. So before deleting this plinth level slab we will change all story option to one story option here. Select all the slab which is exist at the plinth level section here like this. So without selecting one story option to all story option, it will delete all the properties. Click on delete option so that it will delete the properties which is exist at the plinth level section for the structure. So this is the ground floor, this is the first floor, this is the second floor. Now after this we will define the load cases. Go to click on the define option. Select the load patterns. It is consisting of dead load as well as the live load. Now I will define the earthquake load in X direction. You can design this particular building without taking the earthquake load also, but here I am taking earthquake load for simple understanding according to IS Codal Provision Standard System. So here I am selecting seismic loading condition system as the type here. Again after this we have to select the code book. Just I am selecting Indian code 1893-2016. Click on add option. In the same process I am selecting Y direction condition system also. Now I am selecting wind load which is in X direction condition. Select the type which is of wind. Select the auto lateral load according to IS code of 875-2015. Again I am selecting Y direction condition. Click on add option. Now I am selecting seismic load in X direction. Click on modify. Just we will change the zone. Here I am assuming the zone is zone 3 seismic condition system. So here I am selecting this properties. So we will select the soil type as medium condition system only. Click on OK option. After this we will select the earthquake load in Y direction condition system. Click on modify option. Just I am selecting here as Y direction condition for this particular model. So click on select your zone 3. Click on OK. After this we will select the wind load. So here I am assuming wind load effect will be less for this model which is of 39 and placed at a terrain of second terrain with importance factor as 1. And here I am selecting 0.86 is the coefficient. Click on modify option. 0 I am assuming this distance and 180 is the distance for this model. Click on OK. After this we will click on the OK option. Now in the same process I am selecting wind load in Y direction with 39. So here I am selecting terrain category 3. So click on modify option for this particular section. So here I am assuming 0, 180 here. So click on, sorry, not 0, 180. It is 90, 270 for the y direction condition system. So here I am selecting 270. Click on OK. So after this we will click on the OK option. Click on OK option. Now we will assign the loads which is related to dead loading condition, live loading condition, seismic loading condition as well as the wind loading condition. Initially I will apply the dead loading condition system. So in the dead loading condition system, the primary load case is self-weight condition system. Firstly, I am selecting all the building for assigning the self-weight condition system. Go to assign option, joint loads, select the forces here. Add to existing loading condition. We will give the factor as 1, 1, 1, 1, 1, 1 for the particular structure. Click on apply option. After this, we will select the beams for the model. So go to select option. Just I am selecting the properties which is related to the beam section property for the frames. So after this we will apply the load which is of external wall, internal wall, parapet wall loading condition system, which is the addition of 7.5, 13.8 and 3, which is equals to 24.3 as per the calculation part we are done in the previous sections. So 24.3 kilonewton per meter intensity. Click on apply option. So click on OK option. After this we will apply the floor load condition system for the building. For that, go to select option, select properties, slab section, select slab 125, click on select option, close option, assign option, shell area load, uniform, change dead load condition to live load. We will change the load condition system as per school building structure of 3.5 kilonewton per meter square related to IS 875 part 2 code. Click on apply option. Click on OK option. Now after this we will assign the support condition system set the base. Goes to select option for that. Stories which is related to the base. Just I am selecting. Go to assign joint. Select restraints. Click on fixed supports. Click on apply. So after this we will have to click on the OK option for the model so that it will apply the fixed supports at the base. Now we will add the load combination according to our model consideration. Go to click on the define option for that. Click on load combinations. Click on add a default design combination according to concrete frame design, concrete slab design. Click on OK. So click on OK option so that it will add the load combinations here. After this we will do the analysis, analyze, check models. Initially we will join checks. Click on OK. After this we will check for the errors. Model has been checked with no warning messages. Go to click on analyze option, set load cases to run option. We will run a structure so that it will ask you to save the model. Just I am saving the model is school. Click on save option so that it will do the analysis process for the building structural model according to the considered load cases. Now we can see this is the deflection diagram for the building structural model under the considerations of the dead load. We will see the analysis results related to shear force diagram also. Go to click on the display and we will click on the forces, spandular force, select the load and select shear 2 to click on apply option so that it will display the shear force diagram. In the same process, I am selecting moment 33 option here. Click on apply option so that it will display the moment diagram. In the same process, select the torsion. Click on apply so that it will display the torsion diagram according to the analysis. In the same process, if you want to display the reactions, go to click on this display option. Select the forces option, supports and spring reactions. You can click on this. Select any one of the load case according to your consideration. Select the moments as well as the reactions. So if I consider the load combination, it will consider load combination reactions only. So click on apply option so that it will display the complete reactions for the building structural model. So this is the complete process of analysis and modeling of school building by using ETABS software. Designing of the school building G+2 by using ETABS software. So after the analysis process completed, we need to assign the strips for the building structural model for the G+2 building at the ground story level, first story level, second story level. Before that, we need to unlock this model. Click on OK option. Now we will add the strip condition systems. For that, go to edit option here. Click on the edit grid strips option. Click on edit grid strip condition system. Select the story number 4, X direction A. Click on apply option so that it will apply the fourth story strip condition system here like this. Now I am selecting the grid direction which is related to the Y direction with the strip layer is B. Click on apply option so that it will apply the strip condition system in the Y direction condition. Now I am selecting the story number which is related to the third story with X type and A. Click on apply option here. In the same process we will apply the Y direction condition grid direction with the strip layer is B. For that go to select this Y. Again I am selecting B. Click on apply option. Now in the same process we will select the story 2 which is related to the ground story. So this is the first story, story 3 means. So select the story 2 which is of X direction with the strip layer is A. Click on apply option. In the same process we will apply the strip which is related to the Y direction condition system with the strip layer is B. Click on apply option so that it will apply the strip condition system for the remaining slab. Click on OK option. After this, we will do the analysis process for the building structural model with the considerations of the strip condition systems. For that, go to click on the run analysis option so that it will do the analysis process for the building structural model as per the considerations of the strip condition system for the school building. Now you can see this is a deflection diagram. Now we will design the structure. For that, go to design option. Concrete frame. Initially we will check for the IS code by using view revised preferences option. After this we will go to design again, concrete frame. Directly select the start designing check option so that it will start designing of the frame members according to IS 456 2000 code provision standard system. So now we can see it is checking for the designing section of the members according to IS 456 2000 code provision standard system for the school building structure. It was done with complete designing section, but some of the members are failing for this model here like this. So in order to pass this particular member, we need to increase the dimensions of the column sizes. So for that, initially I will unlock the model, click on OK. Now I will increase the dimensions of the column. So go to define option. Just I am selecting section properties, which is a frame section. Just I am selecting the column, modify property. So here I am considering column size which is of, let us take 0.4 cross 0.4 for the building. So again I am selecting this as 400. Again I am selecting assumption as 400 here. Click on OK option. Now we will click on the OK option. Once again we will do the analysis process. Click on the run analysis option so that it will do the analysis process for the building structural model as per the considerations of the assumed 0.4 cross 0.4 load case. Now we will do the designing process. For that go to design option here. Click on the concrete frame design. So we will directly click on the start designing check so that it will start designing check for the members according to IS 456 2000 code provision standard system. So here you can see it was done with complete designing process. So all the members are passing for this building structural model according to the given dimensions. Now after this we will design the slab. Go to select design, concrete slab design, view revised preferences. Firstly we will check for the IS code, click on OK option. Now we will go to design option again, concrete slab design section. Click on the start designing check option. Initially we will select the floors according to the consideration. Click on OK option so that it will start designing of the slab as per the consideration. Here you can see it was done with complete designing section. It is showing the complete strip condition results for this building structural model. So after this we will save this model. Click on Control S option so that the model will be saved here like this. Now we will close the ETABS software. We will open the CSI detailing version software. Now click on the file option. So select the new model option. So open EDB file here. So select the school building. Initially the model will be open in ETABS software. Then after that it will be imported to CSI detailing version software. So here you can see some of the members are failing for this particular structure related to the beams. So you can directly click on OK option. So click on the detailing units option, select metric and SI system, meter, and change the load to kilonewton, kilogram, and this is OK. Select preferences, we will select as per Indian Standard Code 456-2000. Now we will select the rebar rules option. So here I am selecting minimum spacing is 120 for this. Again maximum spacing is just I am assuming 300. In the same process I am selecting the beam. Minimum spacing is 120 I am assuming here. For the zone A, zone B, zone C. In the same process I am assuming 300 for the zone A, zone B also 300, zone C also 300. Just I am selecting the column. Here I am selecting this value as 120. Again I am selecting this maximum spacing as 300. Click on OK option. Now we will click on the OK option for detailing of the structural model. So now we can see it was done with complete detailing of the structural model. You can select any one of the floor framing plan. This is the all rebar plan for the beam. So click on the rebar cage view directly so that it will display the complete reinforcement diagram which is obtained for this ETABS software as per the consider load cases. Now, so this is the reinforcement which is obtained for this particular slab section. In the same process we will click on this beam section detailing, concrete beams, elevation section. You can select any one of the floor. Some of the beams are failing here because of the presence of the extra loading condition system. Now we can see this is the beam designing section at A, B, C. So directly click on the rebar cage view option so that it will display the complete reinforcement design result which is comes under this member. In the same process you can select the column, concrete column 1 section, elevation, select any one of the column so that it will display the complete reinforcement design results for the particular column 1 section under the considerations of the load cases. So this is the complete process of designing of the school building by using ETABS software.